All right, question 3. A local business has 10 exercise stations M to V. The edges of the graph below represent the tracks between the exercise stations. The number on each edge represents the length in kilometers of each track. Amazing. The Sunny Coast cricket coach designs 3 different training programs, all starting at exercise station S. So we're all starting from S here. All right, then you got different types of training things here. A. What is the shortest distance in kilometers covered in training program 1? Well, what's training program 1? The team must run to exercise station 0. O. All right, so what's the shortest way we can go from S to O? For this, I think it's really just trial and error here. So I would say, unless of course you want to use Dijkstra, but what lunatic would do that? We would see that one. So that's 1.8 plus 1.5. That is going to be 3.3. Or we could go this way, which would be 0.6 plus 0.7 plus 0.9, which is, 1 plus 2 as well. 3.4. 1.2, that's no good. So 3.3 is better, so that's definitely not it. What if we went that way? That looks pretty good to me. 0.6 plus 1.2 plus 0.6 plus 0.8. 3.2. That's good. And then hopefully you can see, like, going this way, based on the numbers that are here, will be no good. And going down will be no good. 3.2 will be our answer. But you just have to be thorough and be careful with that, because who knows, maybe if you get one, maybe going back would be the better option. And, so just be careful. Be careful is the moral of the story there. Next one. What is the mathematical term? What mathematical term is used to describe training program 2? A team must run along all tracks just once. Well, if we're just running along all the tracks, that means we need to go along all the edges. Edges, Euler, because they both start with E. So I'm going to write Eulerian. And now you need to figure out whether or not it's going to be a circuit or a trail. Now, the team must run along all tracks just once. And we're starting at S. Does it mention anything about returning to where I'm starting from? No. You're just going along every track once. So I'm going to say it's an Eulerian trail. Remember, if you wrote an Eulerian path, you'd get it wrong. How can you remember it's a trail and not a path? Look at this. You've got an I in Eulerian and an I in trail. And not only that, but think of an Eulerian circuit also has an I in it, as opposed to a cycle, which doesn't have an I in it. So do with that what you will. Next one. At which station would training program 2 finish? All right, so the trail must run along all the tracks just once. Now, that means if it's an Eulerian trail, we're starting, if we just come here for a second, we're starting here because it's 3, which is odd, and I need to end at an odd one as well. So this is 2, this is 2, this is 4, this is 2, this is 4, this is 2, this is 4, this is 4, this is 3. I'm going to end at P. P will be my answer. And then the last one here, which is C, which is my least favorite. I really dislike this question. It says, to complete training program 3 in the minimum distance, one track will need to be repeated. Complete the following sentence by filling in the boxes provided. This track is between exercise station what and exercise station what? Okay, so let's just read what 3 is asking of us. The team must visit each station and return to exercise station S. The team must visit each exercise station and return to exercise station S. Okay, so the team must visit each station and return to exercise station S. So, in other words, in the shortest amount of distance, I need to start at S and return to S. And one of them is going to have to repeat. Now, I just did this by doing a bunch of trial and error here. But I think fundamentally, the take-home message here is that if I just show you what I got once I did my trial and error, so if I did this way, then that way, then that way, then this way. Like this worked well. And then I'm like, then I just need to go back and forward. So I'm repeating this one. Now, obviously, you're going to have to repeat one that is next to S. So it's either you're repeating 1.8, 0.6, and 1, or 1, right? And you want to do it in the minimum amount of time or distance. And this is your smallest number out of those 3 numbers there. So I think that's the thinking behind it. So it's between S and T. But that's a tricky question. Let's look at our examiner's report. Where is it? Let's start with the bottom one. Only 25% of people were able to get that correct, which speaks to the difficultiness of it. Many students were unable to demonstrate an understanding of the requirements of this question. That is an odd sentence right there. Many students were unable to demonstrate an understanding of the requirements of this question. Okay. This one, P, 60% of people got it. This one, Aularian Trail. Some students named the route as a path. Let's just talk about this for a second. Aularian Trail. And the other thing that can be Aularian is a circuit. Okay? What do both of these things have in common? You got an I and an I. An I and an I. So, oh look, there's two I's. So that's the thing you're going to remember. With Hamilton, Hamiltonian path or Hamiltonian cycle, no I's there in path or cycle. There is an I in Hamilton, but let's ignore that. Let's now go to 3A. 3.2. 58% of people got that right. So there you go. That is how you do question 3. Hopefully that has made sense.